In this lesson, we're going to be given two graphs, and we have to decide if they're inverses of each other. So we're going to try to do that instead of using composites like our last video. We're going to do that by actually looking at the graph. So one way to do that would be to draw on the line y equals x. And you want to use a straight edge with this because it's really hard to tell if you don't draw a straight line. So I'm going to try and make mine as good as I can there. So when I look at this line, if I was to fold along this line, do I think both of these lines would be touching? They could be. Think about like looking at different spots, like are they equidistant away from here to here and here to here? Maybe. Looks like this one might be a little bit shorter, but I'm not exactly sure, right? I can't just eyeball it. So one of the things I want you to do is pick some points that you can name on both graphs. For instance, I think I could name these points right here. So I'm going to write them down. We'll call this one f of x. So for these points, I can name negative 1, 2, 3, 4, 5. So negative 5, negative 2, negative 4, 0, negative 3, 2, and negative 2, 4. So all those points I just put in black, I can name those. Now, to find the inverse of those points, remember we just switched x and y. So my inverse function should have these points on them. By flipping, those should be part of my graph. So I'm going to go ahead and plot those points and see if they're part of my graph. So I would have, let's see, negative 2, negative 5, right there, 0, negative 4, 2, negative 3, and 4, negative 2. They're all there, aren't they? So by doing that, I now can say, yes, they are inverses. So let's try number 4. Same idea. I'm going to go ahead and draw on that line y equals x. This one's off just a little bit too. There we go. And I'm going to look at it and say, okay, do they kind of look like they could be inverses? And I think they do, right? They look like they could be inverses. So I'm going to pick some points that I could name. I'll go with my blue line again. Here's some points. So I'm going to go ahead and list those points. So for my f of x, we'll call that one. Doesn't really matter which one we call f of x here. Negative 3, negative 5. Negative 2, negative 3. Negative 1, negative 1. 0, 1. 1, 3. And 2, 5. So my inverse function should have all of those reversed. So negative 5, negative 3, negative 3, negative 2, negative 1, negative 1, 1, 0, 3, 1, and 5, 2. So now as I check that, I'm going to start plotting those and see if they're on my line. So negative 5, negative, oh, look at that. Should have been right there. I already know it's off. I don't even have to plot the rest. That one right there is not on there. We could plot the rest if you want, but see how they have a pattern there? That one would have worked. But this line, this red line, should really be going like this. It looks more like that. So right now I can say no. They are not inverses. Our last one here then, you'll notice we have a parabola. And you're going to have to excuse my red line since I can't always graph non-functions on my graphing thing that I always use for these. I had to hand draw this, so it looks really bad. But if we wanted to see if these are inverses, we're going to plot some points, and we'll pick the blue one again. So like 0, 0, I think I could name these 2 points right here. So I'm going to say for my original function I have negative 1, 4, 0, 0, and 1, 4. So my inverse function should have 4, negative 1, 0, 0, and 4, 1. So as I try to plot that, I have 4, negative 1, I have 0, 0, and I have 4, 1. So I think we can say that these are inverse functions, right? I forgot to draw my line in. Let me do that for you too. The y equals x. They are inverses of each other. And you can see how when you fold across that line, how they could line up, right? Here's the question I have for you, though. It says, let's pretend this function, the blue one, is f of x equals 7x squared. Is the inverse function, so find the inverse function, is it a function? So even if we didn't find the inverse, is this red parabola a function? Hopefully you would say no, because even right here, it's not passing the vertical line test, touching 2 points at once. Sideways parabolas, not functions. So we wouldn't say these are inverse functions, we would say they're inverses. So yes, they are inverses, just not inverse functions.